everyone, welcome to Think Then Code. Today we'll be solving the problem subsequence with minimum score, which appeared as a fourth problem in today's weekly contest. So let's understand the problem. We are having two string s and t, and we have to remove some character from t string so that the string t becomes a subsequence of string s. And there is some cost associated with removing character from t, and that cost is right minus left plus 1. Now what is right and left? Right is the maximum index which we have removed, and left is the minimum index which we have removed. So the cost is right minus left plus 1. So that's what we have to do in the question. Let's see a sample test cases. In the sample test cases, if we remove z from t, then BAA is a subsequence of s. So in that case, the answer is 1 because we only remove z. In this case, we cannot remove anything from t string to form a subsequence of CDE. So we remove entire t string. Hence the answer is 3. The constraint from this problem are 10 to the power 5. So we either have to do a big O of n solution or a n log n solution. Now let's understand the observation behind this problem. So let's assume we are having a string t and we decided to remove 4 characters from it, that is A, B, Z, A, Z, C. So what will be the cost of removal of this 4 character? Here L is 1 and C is 6. So overall cost will be 6 minus 1 plus 1, that is 6. So overall cost to remove this 4 character will be 6. So if we see, even if we remove this C and A also, still the cost to remove the 6 character will remain the same. Why? Because the cost is only dependent on the endpoints L and R. So it doesn't make sense to leave any character between L and R in the string T. Why? Because let's assume if I take all the character from NLR, then the remaining T will be just AA. That is, I only have to match 2 character in a string S. So I have to make only 2 character as a subsequence in string S. But if I leave any character here, let's assume I leave C and A. So then I will be having ACAA. That is 4 size of string to match in string S. So overall, if we take all the character from L to R, our work reduces, and if we leave some character between L to R, our work gets more. So it's greedily better to remove all the character from L to R, that is remove a substring from string T. Now since we are clear that we have to remove a substring from string T, how we will decide that what substring we have to remove? So the answer of L and R can be formed in 3 ways. First, the left can be at the first index and right can be somewhere here. So we will remove this entire portion from the beginning, and the remaining portion at the end will form a subsequence of S. The other way around is the right is at the end of T and left is somewhere here. So we will remove this entire portion, and this remaining front part will be a subsequence of S. And the third thing is left can be somewhere middle, right also will be somewhere in the middle, and we will remove this middle part, and the left part will be a subsequence of S, and this right part will be the remaining subsequence of S. So in this 3 way the answer can be formed. Now let's understand how we will form the answer. We will have left and we will have right. So what we will do is we will build all possible lefts, and for once we have built all possible left, we will get all rights, and for all particular right we will get the best left and form the answer. How we will do this? Let's understand in the dry run. So we have this 2 string S and T, and what we will do is we will build all possible left. So if left comma right is our answer, let's assume this is left and this is right. So if left comma right is the substring we want to remove, everything which is towards the left of the left pointer is a subsequence of S. So what we are doing is we are trying to build this so that we can get all possible lefts. So let's see how we are building this. So we have two pointer PS and PT. PS is pointing to S string and PT is pointing to T string. And also I have created this vector or array that is possible lefts, and it is storing a pair, that is it is an array of pairs, and the first part of the pair is the actual left, that is the starting of the substring which we are going to remove, and the second is S index for left. And what is S index for left? S index is basically till what index in our S string we have gone to form the subsequence. Now what will be the first possible left? The first possible left will be starting from 0 index, that is the beginning of the T string. And since there is nothing towards the left side of the left index, so we have not traveled S index so far, we will store -1 here. That is, we have traveled nothing in S index to match, because towards the left of 0 index we have nothing. So there is no subsequence to match there. Now to build remaining possible lefts, what we will do is first we will keep PS pointer at the 0 index and PT pointer at the 0 index of the T. Now we will keep incrementing the PS pointer until both S at the PS pointer and T at the PT pointer doesn't become equal. So since B is not equal to A here, we will move our pointer forwards. Now since both B are equal, we have the subsequence here. So what is the subsequence? If we keep left here, then this B is a subsequence of this AB, right? So what is the left which we can put in possible left? The left will be PT plus 1, that is the first index. And what is the S index we have traveled so far? We have traveled 0 and we have traveled 1. So possible S will be 1. Moving forward, once we have pushed into our possible lefts array, we increment both our PS and the PT pointer. Now PS pointer will be pointing at the second index and the PT pointer will be pointing at the first index. Now again we will do the same step. We will increment PS pointer until T at the PT pointer and S at the PS pointer become same. Now since they are already same, this BA here is a subsequence of ABA here. So we can keep our left at C. So here we will add another possible left, that is 2. 2 is the left here, and what is the possible S for it? The S index which we have traveled so far is also 2. Let's increment this. In the same way as previous, we increment both PS and PT pointer. Now our PT pointer points at second index and PS pointer points at third index. Again C and C are equal. We will insert the next possible left. The left will be PT plus 1, that is 3, and S will be PS as it is 3. Again we increment our pointers. This points to A and this points to A. Again both are equal. So we push another possible left. The left is PT plus 1, that is 4, and S index for that left is PS, that is 4. So what does this actually mean is BACA is the subsequence of this entire substring of S, that is ABACA. You can see BACA is the subsequence. So once we have pushed this, we increment PS pointer and also increment PT pointer. Now until they are equal, since Z is not equal to B, we increment PS pointer. Again they are not equal, we increment the pointer. Since now they are equal, we push back the possible left. Now the possible left is pt plus 1, that is 5, comma ps, that is 7. These are the all possible lefts that we have built. We can not go forward more because we have ended the s string after this. Now these are the all possible left. Now what we will do is we will in the same way build rights. Now let's have a look what we will do there. Now before we start building our rights, we have to understand how we will pick a optimal left for a particular right. Now let's assume we pick this right. Now how we will pick the optimal left for it? So the first condition that should easily come in your mind is obviously left should be less than or equal to right. Also it should be very close to right, like the closest possible it can be. It can also be L equal to R, but it should be very close to right. The second thing that a L should fulfill is towards the left side of L we are having this substring. Now as we discussed earlier, this substring is a subsequence of S string, right? And here in the possible lefts, what we are doing is we are storing all the S index for particular lefts, right? So if this left part is having some S index, let's call it as X for now. Now towards the right of the R pointer, we also having a substring towards the right of right pointer. Now this substring is also a subsequence of S, because that's how the whole T will be forming a subsequence of S, right? So let's assume this R has a S starting from Y. Now to pick this L, this X should be less than Y. In other words, they should not overlap. That is, S index for both left and the right should not overlap. Why they should not overlap? Because then we are counting a character in S twice. So to explain it with an example, let's assume we are having a S string as A, B, C, E, right? And this is the L and R pointer, and this is the string which is left to the L pointer, and this is the string which is right to the R pointer. Now this ABC is a subsequence starting from S. So ABC, if I form the subsequence, this substring from the starting will have ABC as its subsequence, right? Now in the similar way for DE, we will start from end and we will end until the DE becomes subsequence. So if we start from E, we actually form this DE. So if you see here, this DBC overlaps in both. So this cannot occur, right? In contrary, if I say, if this is the case that we have the string as AABC and CDE, this is the favorable case, because then DE are formed here and AABC is formed here. There is no overlap between the left and the right parts of the subsequence, and that's what we want. That's why we have stored the S index for left, and we will also use the S index for right here. So now let's build the rights and make the answer. What we have done is I have taken the possible lefts and I have initialized answer to 8. This 8 is the size of the T string, because if we remove all the character from T string, empty string is always a subsequence of S. And I have written down the conditions which we saw previously here, that is left should be less than equal to right, and PS, that is S index for left, should be less than PS for right, that is S index for right. Now to get right, what we do is we start from the end of the both strings. So we keep our PS pointer here and we keep our PT pointer here. Now as the same we were doing, we keep decrementing PS pointer until both character at PS and PT don't become equal. So since Z is not equal to A, we decrement it. Now since both A are equal, what will be our right pointer? Our right will be PT minus 1, that is 6 in this case. And what is our PS? PS is also 6. Now we start checking for the possible lefts, right? So what will be the closer left for a particular right? Obviously the closer lefts will be lefts at the end because they are sorted in the ascending order. So starting from the end of the left array, we check these conditions. So for 5,7, is left less than right? Yes, it is less than right. And is PS for left is less than PS for right? No, it's not the case. 7 is greater than 6. So we remove this 5,7 from our array. That is, we do a pop back because it is not a valid left which we can get, right? Now since we are at 4,4, again 4 is less than 6 and the s index for left, that is 4, is also less than 6. Now both are favorable conditions here, hence our answer in this case will be 6 minus 4 plus 1, that is 3. Now since 3 is less than 8, we make our answer as 3. Again, once this step is done, we decrement both PT and PS pointer. So PT will point to B and PS will also point to B. Since both values at PS and PT are same, we can say that the right here is PT minus 1, that is 5, and the PS in this case is also 5. Again we check 4 is less than 5, that is correct, and 4 is also less than 5. So both for S index and left is less than equal to right. So in this case the cost will be 5 minus 4 plus 1, that is 2. So this 2 is less than 3. So we make our answer as 2. Since this step is completed, we decrement both PS and PT pointer. We come here. In this case we come here. Again both are equal, so we update our right and PS. Right becomes equal to PT minus 1, that is 4, and PS is also 4. Now left is less than equal to right. This condition is satisfied, but PS for left, that is 4, is not less than PS for right. So we remove this element from the array and 3,3 becomes the left. Again this condition is satisfied as 3 is less than 4. So the cost for left as 3 and right as 4 will be 4 minus 3 plus 1. It is same as 2, so we don't update our answer. So what does this PT pointer and PS pointer at this represent is ABA, that is towards the right of PT pointer, is a subsequence of ABAZ. So that's the meaning of the all in decrementing pointer which we are doing. We are forming the right part of the T as a subsequence of this right part of string S. Now we will continue the process. We will decrement both PS and PT pointer. So this comes to Z and this comes to C. Since C is not equal to Z, we decrement PS pointer. Again A not equal to Z, we decrement. Again B not equal to Z, we decrement. And finally, since A not equal to Z, we are done with our loop. And this PS is less than equal to 0, we break the loop, and finally we have our answer as 2. So what is the finest T string which we are having? As we saw that ZA, removal of ZA or AZ was the answer. That is 4,5 as left or 3,4 as left was the answer. And if we remove any of it, the final T string which form will be BA, CA, BA. BA, CA and BA, and this BA, CA, BA is a subsequence of S, as you can see, BA, CA, BA. So that's how we build the answer. I hope you understand the dry run. If you did, please like and subscribe. Now let's have a look at the code. So let's have a look at the code. This is the accepted code, 100% on both metrics. First we create a possible left array, that is vector of pair of int comma int, where first from pair is left and the second is s index for left, that is ps for left. Then we create ps and pt pointer because we need them for building possible left. We initialize our answer as t dot size because we can erase entire t string. Then we start building our possible left. PSB left is the possible left array. First we push 0 comma minus 1 because that's the first possible left we have. Then we run this loop to fill all other possible lefts. In this loop we keep incrementing PS until both S and PS and T of PT don't become equal. If we go out of bounds, we break because we won't get a possible left here. If not, we push a possible left into our vector. Possible left is PT plus 1 and corresponding S index for it, that is PS. Once this is done, we increment both PT and PS as we saw in the dry run. Now, since the possible left array is being filled, first we check if possible left back dot first is equal to t dot size or not. So what does this means is the entire t string is a subsequence of s string. Now if t string is a subsequence of s string, we don't have to make any operation on it. That's why we return 0 here. Else what we do is we make our answer as answer equal to minimum of t dot size minus psb dot back dot first. So basically psb dot back dot first is the largest left which we can get. So what does this represent? This represent something which we talked at the beginning of our video, that is we can get 3 types of answer, and one of the type was where r is the last index of t. So basically this, when we delete an entire ending of the t string, so we are taking biggest L possible and r is the last index of the t string. So this is basically the same. Now we again initialize ps as s dot size and pts t dot size minus 1. Why? Because now we will generate possible rights. The upper part of it is very similar to what we are done in generating lefts, just that in left we were incrementing, in rights we are decrementing because we are starting from the end. So the same thing, decrementing ps until s of ps doesn't become equal to pt. If we go index out of bound, we will not get a right, then we break. Since we have a right, we initialize our right as pt minus 1 because that's what right is. We then check the 2 conditions which we saw in the dry run, that is our left should be less than equal to right and s index for left should be less than s index for right. That's what we are doing in this while loop. psb dot size, that is there should be a possible left, and if any of the condition hold true, this is the first condition, that is psb left dot back. What is left dot back? This is the largest left which we can take. Why we are taking the largest left? Because we want our left to be closer to the right so that we can minimize our answer. So this is the largest left. If this is greater than right, then we do pop back. Or if the ps index for left is greater than or equal to ps index for right, that is the s index for left and right are overlapping, then in that case also we do a pop back. Now since we have done the pop back, the possible left at the end of the possible left array is the best left which we can take. So first we make our answer as answer equal to minimum answer comma pt. This is the same as this condition where we have removed a substring starting from t, that is L equal to 0, and we have taken some r. Now we are considering both left and r. Here left is equal to psb dot back dot first and answer equal to minimum of answer right minus left plus 1. That's what it was given in the question. And as we saw in the dry run, we decrement both pt and ps pointer. Once this loop is complete, we will have our answer in the answer variable and we finally return our answer. So let's understand the time and space complexity of this solution. What we are doing in our code is we are just traversing s and t array and we are doing it twice, one for filling left and one for calculating an answer and finding right. So that's all linear operation which we are doing. So the time complexity of this approach is big O of n. Talking about the space complexity, we are creating this vector of possible left. The max it can size go is big O of n, that is the size of the array. So the space complexity of this approach is also big O of n. I hope you got this approach. If you have any doubts, comment. I will try to resolve your query. Also like and subscribe if you haven't already. Hope to see you in the next video.